So what I'd like to do here is briefly discuss some of the features of Linux and Unix. I've been using this for about 20 years now as a programmer. I think that Unix and Linux has been really useful. So I'm just going to kind of go over a few of the things that Linux can do. I'm going to do it very quickly, so if you don't remember everything, that's okay. You can always go back and review it later just to kind of see what's going on. So first thing I'll do is do a directory listing, and I do an ls, which is how we do a directory listing, and it shows that I have an src directory. That's my source directory. That's where typically I would keep my source files. So I can change directory in there. I do a cd to source, and I'll do an ls again and take a look, and notice that I have a few different files: an executable file, cpusuck.c, which is a C source file, and then some various text files, which I'll get to in just a minute. So one thing that is kind of nice to find out, because I'm looking at these files and I may or may not know what kind of files they are. If I type file and an asterisk, the asterisk just means everything. It'll tell me what those files are. So if I take a look here, I notice that cpusuck is an executable file, and that cpusuck.c is an ASCII C program file. And then again, I have these text files. So let's see, another feature is we're able to look at processes, and if I say PS, that'll show me what process I'm using for my shell. And I take a look down here and I notice that TCSH is a process that's running. If I type top, it'll show me the top processes that are running and some various different aspects of what's going on with my particular computer. And if I look at the top, at the upper right, I see a thing that says load average, and it's at 0.00, 0.00, and 0.01. And since Linux is a multitasking system, I can go in and I can start a task and I can have it run in the background while I'm doing other things. So let me quickly show you how that works. So the program was cpusuck, and so I'll go ahead and I'll run that. And notice that I can't, if I type something, nothing's going to happen here. So what I'll do is I'll type Control-Z, and that will put that program, it says it's suspended, and then we can take and we can say BG, and that will put the program in the background. And now when I type top and I look again, I notice that my load average, the first number there, is climbing. It's going up to 0.14, now it's 0.21, and it'll keep going on up and up and up. Because I have one process running, it'll go up to 1.0. And a little bit more on that later. So like again, the ls command shows you what's in the directory, but just typing ls just shows you the files. I can also do a long form, so I'll say ls-l, and that gives me a long listing. And you notice that here we have, for this particular file cpusuck, I have rwx, r-x, r-x. And these are file permissions. As the owner of the file, I have rwx, and that means that I have read and write and execute permission on that file. The next three are for the group that I happen to be in. My user ID is rbrain right here. The group that I'm in is developer. I'm in the developer group. So I have r-x. So anybody else that's in my group, in my developer group, has read and execute privilege on that file, but they don't have write. They can't write to the file, overwrite it, they can't change it at all. And then the other one, this last one here, r-x, is for read and execute for the rest of the world. Anybody who's not in my group can still read and execute that file. And if you go down here, you'll notice that cpusuck.c, it's not an executable file, and so you don't have execute permission on it. Although I could change that, but we'll get to that maybe some other time. And we also notice that, like I said, I'm the owner, rbrain. I'm in the group developer, so all my files that I create by default are going to be in the group developer. This is the file size in bytes. This particular one is 4,729 bytes. cpusuck.c is 53 bytes, etc. The dates that these files were created or last modified is 2011, and that's December 17th, December 19th, and December 16th. And the times that they were created or updated, and then of course the file names. I can also do ls-al, and that gives me a long listing, but it adds a couple extra files in there. These are kind of the hidden files. And you'll notice that we have a dot file, which actually refers to the directory, the current directory. And there's another directory called .. and that's the directory above this particular directory. So if I use the CD again and I go CD .. that's going to take me up to, by doing a print working directory, to home rbrain. If I do CD src again, I'll go back down and I do pwd, and I'm back in home rbrain src. I can do CD .. which means change directory to the current directory, which is kind of dumb, but you can do it anyway. So ls-al shows me all of the files plus the hidden files. And you can have other hidden files in there too. Like I can make, well, I can use the touch command, which will touch a file. It just creates it, touch .hidden. And when I do a plain ls, I don't see this file, or if I do an ls-l, I don't see it there, but ls-al, and lo and behold, there's my .hidden file, and of course it has 0 bytes. Another command that's very useful is the manual command, and it's abbreviated MAN. So I say MAN, I want the manual page on the command ls, and that brings up everything pretty much I want to know about the ls command. And there's the ls-a, that's all the files, including the hidden files, and -A for almost all, and the author, and you can look through here and there's all kinds of different things for the ls command. The man command, you can also do man if you want to find, whoops, I messed up, man. You can find out about the manual section, how to read the different man pages. The particular shell that I'm using, as I mentioned a little earlier, is the TC shell, and it allows you to do various things. If I hit the up arrow here, which I'm doing, it just scrolls through all the previous commands that I've done, and if I go use the down arrow, I can go down. I can use the left arrow to back over, the right arrow. So it's a pretty good shell to use. So there's all different kinds of shells. You can use bash and ZSH, and you can take a look at those. Let's see. Also, when I'm typing out files and I get kind of lazy, which I do, most programmers are kind of lazy. There's a file there called lorem-ipsum.txt. So let's say I want to do ls lorem-ipsum, but I don't want to type that. I type LO at the beginning. That's the first 2 letters of the file, and then I'll hit the tab, and it goes on and it does as much completion of that file as it can. And then we notice that we have lorem-ipsum and lorem-ipsum.txt, so it doesn't know which one I want. So if I type in a dot and then hit tab again, it knows that's unique, and so I can go ahead and do that. That's using the tab. That's tab completion. Another thing that's pretty useful is the tape archive, tar command, and that allows me to take all the files and collect them up into one archive. So what I'm going to do here is look at all my files. There they are displayed, and I want to archive all of those into a tape archive. So I say tar create, I forgot what all these are for, CVF for the files, and I'll put them into rbrain.tar, and then I use the asterisk for all files, and it's going to create this file called rbrain.tar. And now if I do ls-l and I look, here it is, and it's all of the files now been put together, and it's 81,920 bytes. And now what I can do is tar tvf, and that will display all of the files that are in that particular tar archive. And that's a good way you can take and you can put all those files in the archive and then move it somewhere else and expand it out. In fact, let me do that. I'll make a directory called temp, and I'm going to move the rbrain.tar file into temp, and then I will cd to temp, and I'll take a look, and there's my tar file. I'll do tar. Now I'll extract all my files from inside of rbrain.tar and take a look, and sure enough, there they all are. They've all been copied over there from the tar file. One other quick one is you can actually use compression as you're archiving. So I can say tar cv zf, and I'll call it test.tar, and again I'll use all the files. And then if I do a long listing again, I can look, and well, I called it .tar, and that was probably not the best choice. It should have been a TGZ for GNU zip, but the test.tar now has been it's a compressed file, and I can show you actually if I do file star again, it shows you that test.tar is a gzip compressed data file from Unix, blah blah blah. So tar command is really good for moving files around. Now if I go back one last thing, and I go to top again, I want to run top, and it's been cranking along, and we'll notice that the load average now is all the way up to 1, and that's because I have that CPU suck. It does nothing but just sit and spin in a circle, which I'll show you in a second here, and it just consumes CPU. I wrote it specifically just to do what we're talking about here. So I'll quit, just type Q to get out of top, and what I'm going to do is I'll say vi cpu suck.c. VI is the editor that is typically used in Unix, and here's the file. It's a C file, and if you're not familiar with the C programming language, which I'll have another tutorial on that, this is standard for a C-type file. We have an include directive. It includes a standard input-output header at the very top line. We have a main function which returns an integer, and in this case I really don't return anything. And right here all I do is just while one, which just means while something is true, and one is always true, just loop. So it just sits and loops and loops and loops. So hopefully this has been instructive, and hopefully you'll look for more of my videos, and I'll go into detail on a lot more of these things.